The term signal is used in different contexts and can be used for different things. Some examples of signals might be a train signal, a radio signal, a telephone signal, a voltage, but even a bell ringing or a gesture can be considered as signals. What all those signals have in common is that they contain information. In the area of technical signal processing, we're only interested in some signals, namely those that are stored as physical quantities. Hence, in technical signal processing, we don't consider bells or gestures. The signals of interest are very often, for instance, voltages. Many different signals exist, and in order to understand how each signal should be processed, we need to understand the classification of the signals. For example, we distinguish between continuous time and discrete time signals. For continuous time, we use the abbreviation CT, and those signals we denote as x of t, where t is a continuous time and we use round brackets. The abbreviation for discrete time is dt, and those signals will be expressed as a function of k, where k is discrete time, and we'll use rectangular brackets. If a CT signal is not only a function of the continuous time t, but also its amplitude is continuously valued, then this is called an analog signal. On the other hand, if a discrete time signal is not only discrete in time, but also its amplitude is discretely valued, this is called a digital signal. We also distinguish between periodic and aperiodic signals. Periodic signals repeat after a fixed amount of time, which can be expressed for CT signals as x of t is equal to x of small t plus capital T, where capital T is called the period. For aperiodic signals, no such period exists. Examples of periodic signals are sinusoids, such as sine or cosine. We also distinguish between even and odd signals. An even signal xe of t is equal to xe of minus t. An example of a periodic and even signal is the cosine. An example of an aperiodic even signal is the absolute value function. An odd signal xo of t is equal to minus xo of minus t. An example of a periodic odd signal is the sine, and an example for an aperiodic odd signal is the signum function, which is -1 for all negative values of t, +1 for all positive values of t, and 0 for t equals 0. Not all signals are purely even or purely odd, but any signal x of t can be expressed as a sum of its even component xe of t and its odd component xo of t. Further, signals can also be classified as energy or power signals, and we can also distinguish between deterministic and random signals.